right, we're still looking at linear functions, and now we're going to look at graphing some continuous data. So this is example 5. This is continued from the last lesson, and it says an anteater consumes about 35,000 insects each day. Think about that. That's pretty impressive. 35,000 insects a day. All right, explain why the number of insects consumed is a function of the number of days. Find the domain of the function. Is the domain discrete or continuous? And explain. And then graph the function using its domain. All right, so the first thing we need to do is create a table. So I went ahead, we've got our input. Instead of x's and y's, we're using d for the number of days. Okay, so explain why the insect consumed is a function of the number of days. All right, so d represents the number of days. So 0 days, 1 day, 2 days, 3 days, 4 days. That would be your input values. All right, what is your output? Well, it says the anteater consumes about 35,000 insects each day. So on day 1, at the end of day 1, it would be 35,000. At the end of day 2, it would be 70,000, and so on. All right, and then D and N, this is your input and your output. So that makes up your ordered pairs. So the first thing I want you to do is go ahead and pause the video. I want you to make a table, complete the table so that we can decide whether this is discrete or continuous and talk about what we need to do to graph it and answer these questions. All right, check to make sure your input and output table is correct. And again, if you wanted to make a table that went even further, you could. I mean, you could do 5 days, you could do 10 days, you could do 365 days. But what we want to do is just get a few points so that we can determine if this is a linear function or not, and look at the graph and see what it would look like on the graph. All right, so the next thing we need to do is take the table and actually decide how we're going to put that on a graph. So if we think about our input is normally our x value. All right, so we can think of this as normally as our x, and our output is normally our y. So if you think about what that means, our horizontal axis is going to be the number of days. So we can go by a scale of 1, and that will work perfectly fine. Our y values, or our vertical axis, if we go by intervals of 1, then we would never get to these numbers to even have this on the graph. So we're going to have to choose a scale that would include all of these values. So if you want to use a scale that goes by 35,000, 70, 105, 140, you can. You can go by 25,000, 50,000, 75,000, 100,000. You could go by 10,000, 20,000, 30,000, 40,000, 50,000, etc. But you certainly couldn't go by scales of 1 or like 2s or 10s. You're going to have to use great big numbers to have your scale. So once you decide that the number of days is on the bottom and the number of insects consumed, that's the output. The anteater consumes 35,000 insects a day, so that's your output. Then that's going to be determined how you can have your graph. All right, so I'm going to show you an example of how this would look if it were graphed. But again, if you choose to make your scale a little different, it's fine. Just make sure that it makes sense to this set of data. All right, so this example you can see goes from number of days. It does have a scale of 1 through 6, and then it would be continuous if you made it larger. And this one uses 25, 50, 75, 100. People, typically your brains think 25s, you know, it's like easy to calculate for getting a scale to go to big numbers here. But 35,000 would be slightly above 25. You can see it's not on a specific point, but that's okay. 70,000, again, is going to be just under 75,000. And then 105 would be just above 100,000. And day 4, 140 would be just under 150, between 125 and 150. So this is continuous because you can assume that the anteater is going to eat ants, even like if it's eating ants all day long, then they are, if you had a half a day, you could figure out it would eat about half this many insects. Okay, if it was like a fourth of a day, then it would eat about a fourth of this many insects. So you could calculate, so this would be a continuous graph. They also put an arrow on the top, and that is because we don't stop at 4 days. Like it just says that it consumes this many insects each day. There's not a limit on how many days. It just says explain if the number of insects consumed is a function of the number of days. And the answer would be yes, it is. And because it changes at a constant rate, then it is also a linear function. But it is continuous because if you wanted to calculate how many insects an anteater would eat over the course of 1 year, which is 365 days, then you could figure that out. You could multiply the number of days by 365 by the number of insects per day, and you could graph that way, 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 way up here on the graph somewhere if you included all the way out to 365 days. So the reason we include that arrow, it shows that it's continuous. It's going to continue on that same rate of change, and that completes that part. All right, so it says graph the function. Again, you may use a little bit different scale, but you get the idea. This is a great example of how to graph this, but it's certainly not the only scale that you can use. You could use a different scale if you wanted to. So hopefully this helps you understand what a continuous graph looks like, and that it is a linear function, how to find the domain and range, and wow, anteater, maybe I need an anteater around my house to eat more insects because there's a lot of insects in the summer around my house. I had no idea anteaters would eat that many insects in a day. So useful information. All right, last example is writing real life problems. Okay, so when it says writing, that means you have to come up with a real life problem to fit the data shown in each graph. Is the domain of the function discrete or continuous? Explain. All right, so this is very important to our standards. Remember, the success criteria also comes from one of the questions was being able to write a real life problem. So that means you have to be able to make it up on your own. That means there's lots of possible correct solutions. So I'm going to go through and talk about a couple that would fit. Not necessarily the best answer, not necessarily the only correct answer. I'm just going to talk about one answer that would work for each of these. And then I want you to come up with your own answers for these and write those in your notes for your assignment. So write a real life problem to fit the data shown in each graph. Okay, so for graph A, one possibility could be that a person is on a game show and they're answering questions to earn money. And X would be the number of questions that they answer incorrectly, and Y would be the amount of money that they earned. Because it's not possible to answer part of a question incorrectly, then your domain is discrete. That's why it's showing up as just points on here. And again, that's one possible answer for A part. B part, you have a continuous line here. On the bottom, you have 6. This could be 6 days, 6 hours, 6 whatever. Up through here, it goes to 60. So let's talk about what this could be. This could be, one possibility could be a person is biking a total distance of 60 miles at a rate of 10 miles per hour. And this would take them 6 hours to do that if they were biking 10 miles per hour. So X would be the number of hours biked, and Y would be the number of miles remaining. Because you can bike part of an hour, then this shows that the domain is continuous. So you can bike 1.5 hours or 1 3/4 hours or whatever. But if they bike at a continuous rate of 10 miles per hour, then this could represent that scenario. All right, so that's just a couple of examples. Again, that's not the only examples. That's not the best example necessarily. That just gives you an idea to get your brain working, and hopefully you can come up with your own problem for both A and B. All right, if you have any questions, please let me know.